Okay, so now we're recording. So what I'm going to do is I'm going to share my screen, and we're going to go to, not there, we're going to boot up my good friend, our good friend Stella here. And well, I thought we were. Let's see. Hang on here. Unless hang on. There we go. There was a, speaking of lags in the system, there was one right there. All right, hang on just one second. I got multiple screens open here, and sometimes it gets a little silly. All right, so everybody can see my Stella blank electronic paper, I hope.
Yeah.
Yeah, okay, good. All right, so Stella is the package we're going to use. It's the first graphical user interface, or GUI. I guess I have two instances now. Hang on. Yeah, because I clicked twice. There we go, because of the delay. See how delays in the system make it hard to control dynamic systems? It's the first graphical user interface system dynamics package that was ever created. It came out when the Macintosh was introduced. You may remember the Super Bowl in the 84 Super Bowl, where Apple had possibly the most famous Super Bowl commercial, right? Everybody likes to watch the Super Bowl commercials, but normally you go to the restroom, you make a snack or something when commercials are on during football games or whatever, but everybody watches the Super Bowl commercials, right? So they put a lot of effort into them, and they rank the best ones and whatever, as you know. And at the 84 Super Bowl, Apple had a play on the novel by George Orwell, 1984. I don't know if some of you might remember that. I don't know if you're football fans or not.
I don't remember the commercial, but I like the book.
Okay, so anyway, you can find it on YouTube if you want. It's basically Big Brother is IBM, and at the time IBM had pivoted. This is in the early 1980s, from mainframe computing to PCs. They don't do that anymore, but at that time they did. So the IBM PC was the personal computer to have. And Bill Gates made his money by convincing IBM to use Microsoft DOS, disk operating system, for every IBM PC. So that's how Microsoft grew to be a giant company. So they were dominant. Everybody was using an IBM PC with DOS. And then Apple comes around. They had already been around, and they had their own Apple II computer and whatever that was kind of like the Apple version of the PC. But then they announced and came up with this brand new way of doing computing with this thing called a mouse. Nobody had ever seen a mouse before. And icons on a screen and drag and drop and all the graphical user interface stuff that we find just normal today. But it was revolutionary at the time. So they made this commercial where all of the sycophants were watching IBM on the screen, and the Big Brother image, and this a rebel woman takes a giant hammer and twirls it around and throws it at the screen and explodes the screen, and it says 1984 will not be like 1984 in the novel, and introducing the Macintosh. So at the time, Apple had for the Mac, they had MacWrite and MacPaint. Those were the only two software programs. So Apple's plan was to convince people to write software for it. So I actually got a grant for 33 Macintoshes, and I set up a Macintosh lab at the University of Notre Dame. And Apple gave me the computers to, because I was working on economics and system dynamics using Stella. Barry Richmond got a whole bunch of Macintoshes to write Stella. He didn't write it himself. He conceptualized it and had programmers write it. So it was the first, software package to use the Macintosh and Apple machine and to use a graphical user interface. So it was really quite revolutionary. So today there's lots of other System Dynamics packages, and they all use the GUI and whatever. But Stella was the first. It had all those different System Dynamics packages have their strengths and weaknesses. You got to pick one. I have chosen Stella. They're all good. They all have their advantages and disadvantages. The two features that made me select Stella, and actually for years I was a Vensim user. So I was first a Dynamo user, then an NDTran user, then a Micro Dynamo user, then a Stella user, then a PowerSim user, then a Vensim user. Now I'm back to being a Stella user. And it's a giant pain to switch software packages because you have a catalog of models. If you do a lot of System Dynamics, you have hundreds, if not thousands, of models in one format. And now you want to switch over. It's a giant pain. Even if there's a wizard that can help, like open the one model in the old package and convert it, it never converts exactly. You got to do a lot of tweaking and whatever. So it really has to, in my opinion, a new package or an existing package that comes out with a new version has to be really different or have some really compelling features to get somebody to switch. And Stella did that. So what happened was the guy who created it, Barry Richmond, passed away, and his daughters took over the company, and they weren't System Dynamics people, so they sold it to two well-known System Dynamics people who took it over and redid everything and rewrote Stella and came up with all these new features. And that's what got me to switch. So the two big features, and you'll see them as we go along, that really compelled me to conclude this is currently the best System Dynamics package is there's an ability to make games out of your models very easily. And that was previously quite difficult. You had to do a lot of sort of programming, sometimes use another software package like Visual Basic or Java or something like that. It just was really, they had VenApps, but it was clunky. It was just hard to make your model into a game. Now it's quite easy. And number two, there's a feature called Loops That Matter. And when you have nonlinear feedback systems, and you're wondering why a model is behaving the way it is, often the counterintuitive behavior is due to the nonlinearities and shifting feedback loop dominance. You'll see this as we go along. But trying to diagnose when and where that's happening and why it's happening is very difficult. And so finally, we have a software solution that helps us to figure out when you have shifting feedback loop dominance. And Stella is the only package that has that. So those two features made me switch. And so I think it's currently the best package, but everybody has their own opinion on these matters, but that's the one we're going to use. Okay. So when you open Stella, the first thing you should note is that, wow, it looks kind of like a lot of Windows-based software packages. If you're a Mac user, I know it looks similar. I'm not a Mac user, but I know it's, somewhat similar with the sort of the differences between the Mac and Windows systems preserved. That you're always going to have those differences. But anyway, like if I would start at the top here, you would see, well, there's a file menu. And what do we have there? Well, you can create a new model, a new file. That's all, Microsoft Word has that, You can create actually a new causal loop diagram. Again, it's a new model. You can open an existing model or file. You can close it. You can save it. You could save it as something else. And there you can print it. There's you want to password protect it. You can exit. Some of these features I'm just trying to hit the obvious ones that are common to any sort of Windows-based package or GUI-based package. You can tell it to save previously open models so you can get to them right away because you just were working on it. Now, next day you open it up, you want to go right to it. Similarly, if you go to an edit menu, you can undo, redo, cut, copy, paste, delete, select everything, find stuff, zoom in and out. Again, nothing unusual there. That's standard stuff. You can set some preferences for new models and for all models, right? So, you like colors a certain way, you like certain features that are not the default features by the manufacturer. You can establish those. Again, this is very common, right? But as we progress along, now we get into more System Dynamics-ish menu choices. You want to run a model. Well, that's pretty straightforward. Run specs if you want to define, how long your model is going to run for, from time 0 to time 10, from 1980 to 2022, whatever. And there are other features here, importing, exporting data and stuff, that some of which we'll cover in this course. But this is more simulation, System Dynamics-ish stuff that's not common to other packages. And then there's a bunch of windows here that you can open up to do certain things. Certain of them I don't use very much. The message log panel, for example, when Stella sends you messages to the screen, it'll log it. Okay, cool. I tend not to use that very often, but you can, to each his own. There is an assemblies panel. Remember the molecules, the atoms, the generic structures? Well, there you can tap into IC Systems, the company that produces Stella. Their server full of molecules. They call them assemblies. These are little pieces of generic structure that you can just grab, copy, and paste into your model. You don't have to reinvent the wheel. You do have to have an account because your Stella has to talk to the IC Systems server to have access. But also you can invent a molecule and upload it, offer it to the world. So that there's a, sort of crowdsourcing or whatever you want to say, the collection of assemblies. And so this is similar like your GitHub or a place like that where people upload their code for how to do things. So it's a very nice feature. That's quite a new feature, only in the last few releases of Stella. As always, there's many ways to do the same thing in any sort of computer software. So you can go up here and say, I want to run the model. You can do a menu choice. But notice also you can do a Control-R if you're a Windows user to run a model. And also down here, you have in the lower left, you have an arrowhead pointing to the right that runs the model, right? So there's 3 different ways to run a model. This depends on how, do you like keystrokes? Do you like to zoom to the bottom? Do you like to go to menus? Modeler's choice. It's probably possible with a sophisticated mouse to have mouse clicks do it and whatever, so probably the sky's the limit depending on how much you want to get into that. I don't really get into that, but I'm sure some people do. So you just will establish your way of the way you like to work, right? Across the top, we have a bunch of icons or buttons. Not sure what they're technically called. The first 4 are mainly your Lego pieces for building your System Dynamics models. You have, guess what? A rectangle is a stock. Well, wait a minute, let me confuse you. There's a little down arrow there. If you click down, there's a bunch of different kinds of stocks. The default is the second type, a stock. It used to be a non-negative stock in earlier versions of Stella. Let me tell you a funny story. Funny to us, not funny to a guy named George Richardson. So Barry Richmond, who created Stella, would do a lot of consulting for companies, and he would build a lot of models in a group model building session where he'd have a bunch of C-suite managers and him building a model. And he found that when he would go away, they'd want to play with the model. That's a good thing. He had them engaged. But they didn't know how to write good equations yet. And so they would do things like write kind of silly equations, and they'd get negative people, for example, or negative widgets, or whatever the case would be. And they would call him up and say, "This is crazy. What's going on?" And he was like tearing his hair out, because he's like, "We'll get to that, but okay, you're fiddling around." So he put in a feature that said, by default, all stocks never go negative. Even if the equations say they should, no way. That used to be the default. And it used to be a checkbox. You had to uncheck it. You'd have to click on the rectangle icon and say, "I don't want it to be a non-negative stock." So George Richardson was at SUNY Albany teaching a graduate seminar. And Jay Forrester had said repeatedly and written repeatedly that he thought that corporate managers could study on the order of 15 to 20 generic structures in a management education. Remember, Jay always thought that some years after he invented system dynamics, that it would be part of sort of every MBA program. You'd study, accounting and finance and management and marketing and system dynamics. And that there'd be a collection of, let's say, 20 structures, corporate structures, that you would study, and these would represent most of the situations that managers would run into, right? That was his vision. And so George Richardson told his doctoral students, why don't we take a list of some of these archetypes and turn them into these generic structures like Jay was envisioning. So they built the first or second one, and when they ran it, it looked like they had a dynamic phenomenon called chaos. And at the time, it was kind of a hot topic. And George thought that actually they had found a new strange attractor. So in chaotic systems have strange attractors, and they're named after the discoverer. So there's the Roessler attractor, there's the Lorenz attractor, and so forth. So George was getting all excited that maybe he's having a strange attractor named after him, for all he knew. And then one of his students says, "Did you uncheck the negative only, non-negative feature?" George says, "Oh, no, because the stock was not supposed." And when he unchecked it, everything fell apart. He was so mad. He at the System Dynamics conference in Tokyo, at a plenary session, he stood up and ranted and raved at Barry and his company for making that the default version of the software. He was furious, right? So they changed it. So the first change was to make it not the default. You had to opt in, not opt out. You had to proactively check it to make it non-negative. And now the newer owners have, it's just a different stock. And the default stock is, it can be positive or negative. Okay, so there's a bit of history on that. You'll also, there's some other legacy things in here we'll talk about as we go along. They're only in here because of historical reasons, and eventually they're going to fade away. But that's why there's a non-negative stock in a stock. The other three types of stocks we're not going to really talk about in this class because they're more advanced, or they're not part of an introductory course, but therefore more discrete types of situations. So we're doing continuous time modeling, right? Or at least approximating it, because the digital computer cannot take infinitesimally small steps, as we've said. But sometimes situations call for discrete events in a model. And instead of just saying, well, we do continuous simulation, we're going to blow that off. No, there are ways to put discrete stuff in system dynamics models, and it's deemed today to be perfectly acceptable. So you can either write clever equations that do these kind of discrete things, on, off, up, down, black, white kinds of snapping on and off rather than smoothly transitioning. But there's also some canned stuff that allows you to do that. And so conveyors, queues, and ovens are for those sorts of situations. And again, that's beyond this course, but I alert you to the fact that they exist. And as you expand your study of system dynamics, you'll run into these other kinds of stocks, as well as other kinds of equations that will introduce sort of discrete, abrupt, on-off, up-down, black-white stuff into an otherwise continuous model. Okay, so some of that's a little more advanced, but so by and large, we're just going to use the regular stocks in this class. Okay, this is another way of saying it. Okay, then we have flows here. We have flows and biflows. So you got to be a little careful because you use flows or uniflows typically when there's one flow either in or out, or when you want a stock to grow or fill up, you have an inflow, and you want it to drain, you have an outflow, and there's different actors, different information causing the in and out. On the other hand, if you have a net flow all in one place, then you'd want to use a biflow. So we'll be talking about those situations as we go along. I will make that much more clear at the moment. For now, the idea is we have stocks and flows. There's all different kinds of stocks. There's like 5 different kinds of stocks. We're only going to use one, right? And there's 2 kinds of flows, uniflows and biflows. We're going to use them both, but we'll clarify as we go along when you use the one versus when you use the other. And the caution is you got to make sure you remember which one you're using. Because if you think you're using the one and you have the other, it might give you some goofy results. Situational awareness, right? All right, we move along here. Now we have converters, delay converters, summing converters, pathway score, loop score. Oh my gosh, these are all circular icons. By and large, we're going to use just the first one. Sometimes these are called auxiliaries. Forrester always called them, in fact, Forrester called originally these were levels, these were rates, and these were auxiliaries. So Stella has none of the original terminology in it. We're going to primarily use the first one. The only other one you might see is a delay converter. And all that's saying is that there's a canned function inside of there that has a stock in it. So instead of using a stock and the flow and all the stuff that goes along with it, we say, yeah, we know how to do that. I don't want to go through that headache. I'll just use a canned function to represent that stock. It's much easier. But when I look at the model or somebody else looks at the model, we all should know that there's a stock hiding inside there. So it's just, that's a symbol that alerts us to that. So we might use that as well in here. These others, don't worry about them. This is loops that matter and whatever. So some of that stuff is advanced and not to worry about. Then what we have here is we have telephone wires. Okay, and that's what transmits information around the model. And primarily, I think most system dynamics modelers use just the main connector for everything and don't differentiate between information and non-information. Forrester originally did that, and if you look at the original industrial dynamics book and whatever, you'll see different kinds of lines, telephone wires. But I think we're just going to use in this class the first one here, the connector. Okay. So those are the main Lego pieces that we'll use to build all system dynamics models. Okay, so there's not 17 of them, there's only 4. Okay. Suzanne has her hand up. Yes, Suzanne.
So I think I texted the folks at IC Systems and said, what is that information connector for? And they referred me back to Barry Richmond's writing, and they said, we don't know, but it showed up in some of his stuff and it's just in there in case you want to use it. And so to me, that seems like a potentially useful tool if you're modeling some softer systems. Like maybe in the decision.
I think it goes back. I think it's a legacy system that Jay differentiated between like smoothing information and moving people or widgets or something like that. That's my understanding of it. So okay. Yeah, even the IC system, I think people who create it are scratching their heads. But a lot of this stuff is legacy because if somebody has an older version of Stella or catalog of models of old made with old Stella, they want the new Stella to be able to open it and use it and whatever, and not offend those customers, right? So they keep a lot of stuff in here that probably wouldn't normally be there for that reason. I'll give you another example. It's coming up. So the next thing to note is modules versus sectors. Don't worry about the placeholders. Modules versus sectors. So you're going to see me saying sector, but using the module icon. That's how I think about it. Modules are technically different from sectors, but modules are used to sectorize a model. It's a legacy thing. The sectors are going to be going away at some point, but they are a legacy thing. Older versions of Stella, models created with older versions of Stella have the sectors in there. Some people actually prefer them to modules, so maybe they won't go away. You know, you get enough customers saying to keep them, they'll keep them. So modules and sectors are ways to compartmentalize or modularize your models. And there are different ways of doing it. I prefer modules to sectors, and I call modules sectors, even though they're technically in the Stella environment, modules. Okay, and we'll be showing you how to use those as we go along. So those are quite useful when you have larger models. Yeah, I mean, you can use them at models of any size, but it's unnecessary for smaller models. But bigger models, it makes a lot of sense. Then we have a ghost icon. That's supposed to be a little ghost right here. And a ghost, is used to make a copy of a variable. So if you have a giant model, instead of taking one of those red connectors and stretching it way across your electronic paper, or even if it's close by, if you got to cross all sorts of stuff to make it connect, it's a lot easier to make a copy of it and plop the copy right next to where you want it and draw a little teeny arrow. So that's the main use of the ghost. Okay. Again, this is sweeping overview stuff. So you're not expected, based on my comments right now, to like, oh, I understand everything. It's just giving you the basic lay of the land here. Here's a text tool. Okay. The main ones are a text box. You can put commentary in your models. You can put commentary, in your models next to the stock flow feedback loop structure. That's often useful. You can put commentary, as we'll see, inside of an icon. That's also useful. Documenting your models for others or for yourself is very useful. So even if you built the model and 7 weeks have passed and you reopen a version of it and you're like, what did I do here? You have 54 versions of the thing. Version 17, what happened there? I don't remember. Let alone if somebody else is trying to understand what you've done. So documenting your models, and there's all different ways or places you can document, is very valuable. So using text box on the screen next to a variable that says, this variable does the following, or I will hook up something here. That's just good to know, right? Loop labels. So you can, again, trying to make your model more understandable. If you have particular feedback loops that are obvious, sometimes and often they're not obvious, but if they're obvious, you might want to document them and put a little loop label and say, this is a positive loop or negative loop, whatever. You can put in some stuff to have for bigger models to zoom to different places very quickly if you want as well. That's what that's for. You can put pictures in your model. So if you're, making a model of military leadership, you might want picture George Patton next to the model or something. I don't know, whatever. Over here, we start getting into, in fact, if you plop it down to one, hit the delete key. Now we start outputting results of models. We can make graphs, we can make tables, and we can just say, show me the number of the whatever on the screen. Okay, so we have the Lego pieces here. We have the sectorization tool here. We have the copy tool here. We have the commentary tool here. We can put a picture in if we want. And then we have output tools here when we want to see the results of the model in graphical form, tabular form, or just show me a number. Okay. Now, coming over here, there's some tools that are either super useful or less useful, in my opinion. Depends on how you work. So if it's less useful to me, you might find it useful. Depends on what you do. So here's another legacy thing. Okay. The map view is used to hide warning signs in your model. So if I were to take a stock and plop it down and be in model view, and I'm going to make this bigger. You go up to the upper right here, you can make things bigger so people can see. It's one way to do it. That's a zoom feature. Notice the warning triangle there. In older versions of Stella, it used to be a question mark. Either way, Stella is telling you, you got to give me some more information. I don't know what, there's a stock here. Okay, I get that. I, Stella, get that. But you got to give me more information. In the case of a stock, it's going to want to know the initial value. How much stuff is in that bathtub called stock 1 at time 0, the start of the, or at the start of the simulation. And it's not going to let you run the model until you fix that. Like I say, it used to be a question mark. Well, again, Barry Richmond would do consulting, and he'd leave the consulting engagement at the end of the week and leave the model. And he'd get phone calls and emails saying, I can't stand these damn question marks. Why are they there? They're freaking me out. They're bothering me. Or even during a brainstorming session. And so he's like, fine. Okay. So he has a feature that says you can just turn them off. And they remain. This feature remains. It's a legacy feature. Most packages, in fact, I don't think any other System Dynamics package has that feature. But so here you have no idea where the clinkers are, at least not visually. And here, yes, it tells you. Go figure. I don't know. Human psychology. Who knows? Suggest view. I'm not entirely sure what suggest view is. I've never used that feature. So who knows? By the way, to get rid of stuff, select it and hit the delete key. Used to be in Stella, to delete something, there was a dynamite stick. You'd have to blow it up. Now you just hit the delete key. Okay. Other things to note. The magnifying glass here is, you'll see when you want to see the results of a simulation. So you'll run the model and it'll have your simulation results. You'll have your loops that matter information, whatever. If you click off of that, that stuff goes away. And instead of rerunning the model, you can just say, okay, show me that again. So the magnifying glass is going to help you do that. Here, you're going to, with this little icon here, it's grayed out because we don't have anything on here. You can switch when you have a model between the model and just the causal loop diagram. So if you have a model, you can say, just show me the feedback loops in causal loop diagram format. You can't go the other way. You can't go up here and say a new causal loop diagram and just draw a causal loop and then say, now switch it into a working model. There's not enough information. You can't do that. But if you have a working model, you can say, get rid of all the stuff except the feedback loops and show me a causal loop diagram. That's that tool over here. Again, some of this stuff, don't worry about at the moment, except for this one here. This icon takes you, if you have Stella Architect, which I have, to the interface that allows you to make a game out of your model. And so then you can switch back and forth between the model and the gaming interface. And that is super, super, super useful. Okay. All right. Again, sweeping overview. I'm quite sure you're saying, I don't remember everything the guy said, but just getting your initial bearings here. Okay. Down at the bottom here, there's several buttons that are quite useful. I mentioned the run button. You can stop a run, mid run if you want. This little icon here that looks like big disks on a server is where you have your data runs. So if you want to, you have a base run and 5 simulation experiments, and you want to name the runs and compare them, you would go here and you would do that in this window. You'll see that as we go along. The U-turn says, all right, I want to manipulate some parameters in my model to see, just for giggles, to see what happens. Now I want to put everything back to where it was. You hit the U-turn button, it puts everything back. Again, you'll see all these things in action as we go along. Okay. Now, the only other thing before we start actually building a model I want to call your attention to is way over here on the right side. I'm hoping you guys can see it. There's a little arrowhead here pointing to the left. Can you all see that? Over here. I don't know if it's obscured. So if I click on it, now the arrowhead's pointing to the right. So it just opens and closes a panel. Okay. And a lot of software programs work this way. You can have panels on the right and left. So you have your working code writing or system dynamics model or whatever in the center. And then you have panels off to the side that allow you to manipulate stuff. And they close and open. You can undock them and move them around if you want them at the bottom instead of the side. You can do that. This is the default setup. Okay. So when you can use the little arrow here to open and close the panel, or you can double left click in the electronic paper anywhere. Now, where it gets confusing is this. Watch this. Here's where people get confused. Now, let me get a stock. So I'm going to left click and my hand is not on the button. I'm just going to roll the mouse. So there's no button pushing. I'm rolling the mouse. And then I'm going to left click again. So I plop down a stock. Okay, now watch the difference. If I click off of the stock anywhere, I get a panel for the whole model. But if I double click over here, I get a panel just for the stock. And people at the beginning get confused as to which panel am I in. So if I click off of an icon, it's for the whole model. If I double click, I should say, on an icon, it's just for that icon. Okay. So you got to know where you're clicking. Okay. And then you click away, it goes away. And then you can always open these panels and close them with the arrowhead if you want. Okay. All right. So that's how hard can it be? That's kind of everything. And the delete key, if you select it and hit the delete key if you want to get rid of it. Okay. So far, any questions, or do we kind of get, again, just basic sweeping overview?
I don't have any questions about the program itself, but I've been able to get onto the free Stella software online, but I'm having some issues getting onto the full software through WPI. Is anyone else having that issue?
That's a great question because they just upgraded to the latest Stella, the university did.
Okay.
So I don't know if something's goofed up, because sometimes when they update things like that, they change something and they don't tell anybody.
It very much could be user error, but I had downloaded the VPN and it just keeps sending me on a loop to other VPNs on the website. So I just was wondering if I was the only one.
Okay. Yeah, I don't know. That's a great, since I don't have to do that, I am not experienced with that kind of situation, but you do need the VPN. So no matter where you're at, the WPI servers think you're on campus, right? When you're using the WPI VPN. And then it resides on specific servers, right? And obviously you need your university credentials to get in there. But beyond that, if there's a IT thing, I don't have an answer for you guys.
Okay.
Probably bears investigation. Now, IC Systems probably, I'm sure they do has a student price for this stuff. So you may want to investigate what that is. I don't know what it is. Again, I'm not a student, so
It's about like 120 for a year, or actually no, for unlimited license. It just doesn't come with the updates.
Okay. So I mean, so it's, it's not a horrible price, but it's not $10 or so. So you can decide. The problem with the free stuff is it's quite limited.
Yeah.
You should be able to get through this course with the free stuff, because we're not going to literally build giant models. The big models are going to be available. I've built them and you're going to just use them. But if you want to build bigger models, you're going to need one of the 4Pay packages. But you could, I think, get through this class avoiding that. And then, of course, trying to get access to the university's full-blown Stella Architect is not a bad idea. Obviously, you need university credentials to get in there. So Suzanne and probably Neja are out of luck for now on that. But so, all right. Anyways, so there's that. Yeah. All right. So let's press on. So, sweeping overview. So let's see if we can begin to build some little models here, little molecules, and begin to get a little more acquainted with the software. So I'm going to grab a stock here and I'm going to plop it down somewhere on my electronic paper. So I left clicked, I took my finger off the button, I rolled out, then I clicked again and plopped it where I wanted it to be. Notice these little, I don't know what they're called, Bezier handles or whatever they're called. You can make these stocks bigger or small, you can make it giant if you want. I mean, I'm not sure why you'd want to do that, but you could. You go up to the edit menu and say undo it and back to where it was. Okay. And we got that warning sign indicating, all right, I still expect you to write an equation here. Okay. Notice down to the lower right here. And again, I hope you can see it on your screens. It says there's one invalid equation. So it's Stella tries, as do many programming environments, to help you diagnose errors, right? And these things are imperfect, but they at least give you hints as to where a problem might be. So it's saying there's an invalid equation, but we know that because we got the warning sign here. Again, if you want the warning sign to go away, you can go to map view and say, I don't like seeing those things. Again, for certain situations, brainstorming or whatever, maybe that's okay. I don't know. But model view says, no, we'll show you all the warts and bumps and hideous mistakes. All right, so we just put down a stock, right? And again, I go upper right if I want to make it even a little bigger. We can do that. So now let me go over here and let me get a flow. Again, I left click. I come down and I just plopped it. And look at, I got some handles here, so I can go over here and attach it and make it, see, I don't know if you can see the little blue dotted line there when they're aligned. Some people don't care if their stuff is aligned. They'll do stuff like this. They don't care. You'll see it in journal articles. I care. I don't like to see that. I like my stuff aligned as much as possible. You're never going to be perfect, but to try and make a tidy diagram. Okay, so we've got a system dynamics model here that will actually do something when we tidy up these warning signs. Okay, now remember, if I were to double click, I should say, on any icon, it opens a panel for that icon. And if I double click anywhere else, it's going to open a panel for the whole model. Okay, I want to reinforce that. Okay, now as long as I clicked over here, let's see what we got here. Start time 0, stop time 100. 100 what? Months. That's just the default. There's nothing that says it has to be that. You could say time if you wanted. That's perfectly okay. 100 is maybe, well, for now, let's leave that be. Here's our old friend DT, right? Step size, right? So we've discussed that and seen PowerPoint shows and all that. You can't make DT infinitesimally small. As we've said, you're going to, at some point, hit round off error. And if you make it too big, you're going to have integration error. Okay. If you want to see it in a fractional form, you can do that. Either way. Simulation duration. So in the old days, when computers were really clunky and slow, you would do anything to speed up your simulation. Simulation duration lets you slow down your simulation. Why in the heck would you ever want to slow down? Well, because sometimes you want to see the thing unfold. And with a modern computer, you don't even see it, just appears. That's okay. Except if you want to see something unfolding and sort of think about it as it's unfolding, you want to slow it down. So you can do that right here with this parameter. Again, you can say time, you can say year, it doesn't matter. It's up to you. Down here, what do we got here? Euler's method. There's our good friend Euler. That's adding up the area of the rectangles, right? Then we got a couple of Runge-Kutta methods. Those are much more sophisticated, Taylor series expansions and all that, but they're much more accurate for the same step size. Okay. And there's a cycle time thing that's a little bit of a special case. We don't have to worry about that here. Calculate loop dominance over here. This is that loops that matter thing. And that's one of the two reasons, the other being this icon here, so I could make a game out of it easily, that I switched to Stella. Okay, so if you have that on and a bigger model, things are going to run more slowly. So, you might not want to turn that on with a bigger model initially, and only later on when you want to start investigating the feedback loop dominance, turn it on. But up to you. With small models, it's not going to matter. Okay. There's a bunch of stuff that you can set here that's personal preference. Stuff like, how do you want your pages numbered? If you want to print out your model and it's on pages, do you want them numbered by rows or columns? You want it in landscape or portrait mode and all that kind of stuff. Now, to further confuse you, there are buttons down at the bottom here, or maybe they're tabs, not sure. So, I said if you click on a icon, you go to a panel for the icon, and if you click anywhere in the electronic paper, you get a whole model panel. But look at this. If you click down here, now it changes. So again, at the beginning, it's like, where am I? So you go over here and you see this and you're expecting this. It kind of throws you at the beginning. So you not only have to know that I'm clicking on an icon versus I'm clicking on the electronic paper, but what button am I activating on these things? There's buttons down here too for the icons. See? So again, it's a little bit it can get to be a tad confusing sometimes. You just got to play around with it a little bit and be a little detail oriented until you get familiar with it. And then it's quite simple once you're familiar with it. Okay. All right. So I have a simple system dynamics model. It's not going to run yet. I got a stock and a flow and no equations have been specified. Now, what you're going to find is that you're going to develop a modeling style as you go along. It's kind of funny. I'm naming these things. It's kind of funny. You can tell, if you're an experienced system dynamics person, you can often tell who created a particular model without seeing anybody's name attached or whatever, because they have a particular style. Like Khalid Saeed, who I've known I met Khalid in 1983. I've known him 40 years. Been doing system dynamics together for 40 years. His models look very different from mine. And I can tell a Saeed model pretty much just by looking at it. I don't have to see anybody's name anywhere. On the other hand, he always says to me, your models look like Sturman's models. And I'm like, yeah, because I sat next to John Sturman in his office for a year and a half doing models. So I'm not surprised that my models look like Sturman's models. My doctoral student, well, he's actually graduated. He's a PhD now. Suleiman Ba, his models look exactly like mine. Like exactly. I'm like, is that my model? No, it's my model. It looks like my model. He goes, well, you taught me. So you develop a style, and your style is often, in my experience, you imitate the person who teaches you, and then you modify as you become your own modeling person. right? And so your model kind of looks sort of like so-and-so's, but you have your own twists and turns. And it's just a matter of preference. How do you like to do your work? How do you think about things, right? And we'll be talking about this as we go along. More about, in the second course I teach, we get more into modeling style, because we'll build bigger models, and keeping track of stuff is an issue, and having a good style or a good method for doing that's quite important. At any rate, having said that, look at here. My style is to initialize my stocks outside of the stocks. This is not mandatory, but I like to do it, and I'll show you why as we go along. So what I'll do is, particularly if I have a long stock name, retailer inventory of beer, I'll just copy that and then get a converter and type initial and say initial paste, initial retailer's inventory of beer, rather than typing that all out again. I always do that. That's my style. And I try to align it, you see the little blue dotted line, with the stock if I can. Often I can't do that because there's other stuff in the way, but that's just what I like to do. And I'll show you why as we go along here. So now I've got 3 icons, which means I got 3 equations that need to be identified or need to be specified, or Stella won't let me run the model. Okay, so let's start with population. It could be the population of honeybees, cells in a petri dish, people, doesn't matter. We'll double click here. And what I'm going to do is, watch what I do here. I type in INI. I just typed in INI, and it says, all right, you're looking for something with INI at the beginning. And the only thing out there is initial population. So the stock icon has a warning sign because it's looking for its initial value. Initially, how much stuff is in the tub. Instead of putting a number in there, I'm saying the initial amount in the tub is named population, is initial population. But I could have easily put a number in here or an equation in here, but that's how I choose to do it. And down here, let's say it's people. Okay, so now I have units of measurement. Remember how we said stocks are in terms of units, flows are in terms of units per time, and that has to hold through every feedback loop and every stock flow relationship, or you have dimensionally incorrect equations. And it can get tricky. Remember the acceleration, velocity, position example. So you'll see that as we go along. It's a little bit tricky, but it's really helpful to know your dimensions because it helps you specify equations correctly. So not clear at the moment, but keep that in your hip pocket, because as we go along, you'll see how it's quite valuable. Stocks are in terms of units, people. So let's say there's initially 10 people. If I type in P, it's going to give me everything with a P in it. So people, so I didn't have to type it out if I didn't want to. Okay. And look at the warning things went away. Warning triangles went away. Stella doesn't know if the equations are correct, but Stella is saying, all right, you gave me equations. Whether or not they're correct, that's up to you, Mike, but And how about the flow? Well, notice we specified uniflow. If I wanted a biflow, now things can go both ways. I don't in this example, but if I did, that's how I could change it. Or I could have selected up here, biflow. Okay. And I'm just going to say 2. Now look at down here. I didn't have to type in any dimensions. This is another innovation in Stella. Stella has a lot of innovative things that speed up the modeling process, like just not having to type that in. I know, and Stella knows, that if this is in terms of people, that's the units. This has to be people per time, right? And we know time is year because we told it. So it's saying this is people, the model's in year, so this has to be people per year. And it does it for you. All the other packages, you got to type that in. Or, type in P and then select it, right? So that's kind of nice. All right. Guess what? We have the simplest dynamic system in the world. One stock and one flow. And this model should run. Now, if it runs, we want to see what's happening. So I went up here, see this icon up here, and I got a graph button, I guess you call it. And I plopped it down. Let me do that again. So I click, fingers are off the buttons. I roll into the electronic paper. Now I hit that left mouse button again, and there it is. There's a graph. What do I want to graph on here? Now look what I can do. This is a graphical user interface thing. I can grab population and drag it in here and let it go. And now you see it says, all right, you want to graph population. Now, another way to do that, I could have double click. So we talked about double clicking on the electronic paper, double clicking on an icon. Now look, I double click on a graph, another panel comes up. Again, which panel am I in? That's, again, it's got buttons down at the bottom or tabs or whatever these things are. So again, it can be a little bit confusing. You got what panel am I in and what button do I have clicked? But notice it says population here. Look at the little minus button. Now it's gone. If I take the plus sign, oh, there's a list of all the variables here. And if it's a really long list, I can, have it find it for me. And if I click on it and say, okay, it's another way to do it. So we're going to graph population here. When you make a graph, what you're doing is graphing ordered pairs, right? So if you want to literally see the ordered pairs, you can get a table. And again, I can drag and drop in here. Now it says, okay, you want to see the numbers for population, or I can double click on here and the panel comes up and see it's already in there. I could get rid of it, hit the plus sign and say, I want to see the numbers for population. Okay, so how do you want to see your data? Two ways of seeing it are, in terms of the numbers, in terms of the graph, the numbers that are being graphed. Either way. All right, how are we going to run this thing? Well, here's our run button down here. Or we could go up here and say, run or Control R, doesn't matter. I like to use that button. And we ran it for 100 years. According to, it's going horizontally here. Because it went for 100 years, but we started at year 0, so it's 99. Remember, we started with 10. Look at over here. We started with 10. We added 2 every year for 100 years. So we added 200 people, 2 plus 4 plus 6 plus 8. The stock is accumulating or summing up. And we started with 10, so I should have 210 at the end. Now look at here. I click and hold. I click and hold, and there it is, 210. If you see, it's another way to know. If I want to go back in time, the time tunnel, very few of you are going to know that reference from the 1960s. When I was a kid, I loved that TV show, The Time Tunnel. The star of the show would run into this tunnel and go back in time and then do something with a historical figure. About age 35, I found out that you couldn't really do that. But you can do it in the virtual environment. We can go back in time. Look at that, to anywhere we want. So you can have the numbers or the graph. Now look at here, vertical time. See, I'd rather see it going top to bottom rather than left to right. Again, so see it. We started with 10, we added 2, we added 2, we added 2, and so forth. Okay, any questions on that so far? Again, that should be fairly straightforward, but again, when people are new, it's just a matter of maneuvering. It's not that this is intellectually difficult. It's just that maneuvering around can be a little bit difficult at first to get familiar. It's to me, it's like swimming or driving a car. I can lecture to you on how to swim. You put your face in the water, you lift your elbow up, you stretch out, you rotate a little bit, you stretch out, or you check your blind spot, you put it into drive, you give it some gas, you pull out into, and some of that's valuable, but you learn how to drive or to swim by getting in the pool or pulling out into traffic. You learn how to do this by hearing me talk about it, but you got to actually grab the friggin' software and just start doing it. That's the only way to really learn how to do it. And then you're like, okay, I got to go back to the tape because Radzicki said something about whatever, and I didn't quite catch it at the time because he was kind of going fast. But now I'm kind of stuck, and I think I kind of remember he said something about it, right? And then you circle back. It's like, okay, I got it. Okay, and it goes into the memory bank, right? All right. So how are we doing? Any issues, or everybody's kind of following along at home?
That's very helpful. Are you going to show us how to do the multiple runs and the undo and all that?
Yeah, sure, of course. So, well, all right. So why do I initialize my stocks outside of the stock? Now watch this. We go back up to the hourglass here, and I hit it. See, now I got the run back. If I click off of it, double click off of it, the run goes away. So I want that run back over here. Okay. And looky here. I started with 10, but what if I started with 20 or something? Okay. There's 20. I just twirled my little knob here, and now I was up to 220. Makes sense. I added 2 a year for 100 years, but I started with 20. Okay. But you can easily test something like that. Now that's very useful when you've got a model and you're saying, do I have a sensitive parameter here? Like if this was bigger, does it make a big difference or not? Or do all the negative loops sort of compensate for it? And it, you don't get much of a difference. You have policy resistance. So you just twirl a little knob, see what you got, right? That's very useful. Okay. When you're trying to put a model into equilibrium, it's often useful to be able to twirl a parameter knob and say, am I even on the right track here? And you say, like, if I twirl it a little bit, do I get equilibrium or close? And if I do, okay, I'm on the right track. So that feature is quite nice to have. And guess what? Look at here, U-turn. I guess it's not going to let me do this. It's going to make me resimulate, but that's okay. And so I'm back to where I was, but it put the parameters back. Okay, so that's that U-turn button down here. So if you mess with that and you learn something, you U-turn it and just resimulate, you go back to where you were. Okay. Now, how about runs and multiple runs? So over here it says run 1. Okay. Now, as we go along, you're going to see we'll probably call that one base for base run. You could call it base run. The longer you make the names, policy experiment 1, tax decreased by 5%. Well, you could put all that in there, but if you have 11 simulation experiments on the same graph, it's going to be like chaos, right? So it's one of these things where, you might want to have a legend. You could use the text tool over here to say, run 1 equals tax increase by 5%. And then and then you look on the graph, it says run 1, and you don't have to have all that jumble stuff in there. So we this going down to this icon here, we can name runs. We can save them and say, don't delete them. We can specify how many runs we want at a time before it starts getting rid of stuff. So if you say 5 is the default. See, it says delete runs over the threshold. You can turn that off, but it's going to start. It's only going to keep 5. So when you run the 6th one, it's going to drop the first one. Now, if that's your base run, you don't want it to do that, right? So you might want to say, save the base run and then delete runs past the threshold or whatever you want to do. But it allows you to keep track of your various simulation experiments or runs when you're just trying to build the model and you're just trying to see if something works or not. Okay. All right. How about this? Let's put this back up here. Let's go the other way. So we're going down, 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 no. One of the problems is sometimes it's hard to get this thing right to an exact number you want. There's 0. All right. So I started the bathtub at 0. There's nothing in my tub to begin with. And if it's a bathtub, if it was instead of population, let's say it was water. and there's nothing in my tub. My tub is empty. I'm going to take a bath. More like, I don't take bath, I take showers, but I give my dog a bath. And the birth rate would be, you know, the inflow of the water into the tub to give the dog a bath, and you turn it on. That would make sense, right? Does that make sense if we have population of people, of dogs, of bacteria, of money, anything like that? Something's growing. Does that make sense? The model works mathematically. It is dimensionally correct. So the math is correct. The dimensions are correct. Stella likes it. It worked. But is there a problem here? So now we're in the area of domain knowledge, not system dynamics modeling knowledge. So let's talk to the veterinarian. To make more dogs, we call puppies, what do you need?
You need male dogs and female dogs.
Okay, and the population is initially,
2.
no. We rolled the dial.
Oh, we have 0.
Yes.
Hmm.
To earn interest, if that was cash in your account instead of population, and the birth rate was the interest earned, but you had nothing in your account.
So it doesn't pick up on those errors.
Yeah, it's
Okay.
mathematically correct, but it's conceptually silly. You can't make babies without starting with people. You can't make money or earn interest on money without starting with money, and so forth, right? You can't make more machines from machines without starting with machines, right? So it's conceptually wrong, but mathematically correct. So here is another reason you got to be, you know, it looks easy.
So what happens if Mike, what happens if we put 2 in there? I mean, how do you know if they're
Oh, we
one male, one
had that,
female?
so we go back to that. So now it's all right if there were just 2 being added. Now, if it's 2 gallons of water every minute, and time was minutes instead of years or something, that would be fine. Make more sense, but it's okay now. I mean, excuse me, there's nothing alarming at the moment here now, but it's not a robust model. It doesn't make domain sense. You need people to make people. You need cells to make cells. You need money to make more money, and so forth, right? So how do we fix the conceptual problem?
I mean, don't we have to have feedback from the population to the birth rate? Was there-
Feedback.
Yeah.
Feedback is the answer. We need feedback. Okay, so how do we get feedback? Remember, feedback is the transmission and return of information. Information on what? Information about the amount of stuff that's in a system stock or stocks at every point in time. So let's get a connector, a telephone wire, and we're going to click. Now I am holding. See, if I let it go, it disappears. If I hit that, if I hold the hit the Alt key and hold it on a Windows machine, the Alt key, I get the same tool back. Now the Alt key's off, but I'm holding. See, I'm holding the mouse button, the left mouse button, and I'm going to stretch it. Okay, and you can move it around. If I said, "Oh, I shouldn't have done that," you can pull it off. It goes away. Alt key, it comes back. I can put it back. Now, when I did that, what happened? The warning thing came back, right? Because it's saying, now you just told me, Mike, that population has to be used in the equation for the flow, and you're not using it. See, this is unused input, population. They still saying you stretch that link, so you're telling me population has to be used in that flow equation, and it's currently not. So I'm going to put up a warning sign. Now, what we need here is some kind of productivity measure. How many babies can each person make, or how many bunnies can each rabbit make, or whatever. So if it was rabbits, this is the population of rabbits, this might be bunnies per rabbit this is in years, right? And this would be bunnies. This would be bunnies. This is, of course, bunnies per year. It does it for me. That's cool. And now it's saying, you've got to use both of these guys somehow. You can't just have a 2 in there. So think about it. If population is bunnies and the fertility coefficient is bunnies per my bad. Call this rabbits. Call this rabbits. Because we're distinguishing between, bunnies are rabbits, but so what I want to say for the fertility coefficient is bunnies per rabbit per year. Okay, so that's the number of bunnies each rabbit can make in a year's amount of time. It's a productivity measure. It could be widgets per worker per day. That would be another productivity measure, right? And think about it over here. This has to be rabbits per year. So this would be rabbits times bunnies per rabbit per year. That has to give me bunnies per year, because the rabbits are going to cancel out. But the problem is Stella needs to know that rabbits and bunnies are the same. Bunnies are rabbits too. So let's see, how do we do it over here? This one, parameter control. This one I don't do very often. Let's see, open spell check. Hang on here. It's one of these windows. Compare with equation viewer, data manager, macro manager. You got to be able to tell it. Oh, I don't remember which one. Where you got to tell Stella that bunnies and rabbits are the same thing, because you can say people, managers, workers. Well, the managers and workers are people too. So let's see. Can't remember results. No. What is compare? Is it compare with? No, it's not that either. It's they when they do these packages, they change the names and where they put these things, and I can't remember here. I don't think it's the equation viewer. See, it's putting these equations in here. No. I'll have to circle back. I don't remember. Somewhere there is, it might be over. I'll have to circle back and tell you. I can't remember where you tell it that. But you have to tell it that, otherwise it's going to give you the errors. Anyway, all right, sorry, my bad. I'll get back to you on that. All right, so then you give it some kind of weight or parameter for the fertility coefficient. We're starting with 10. Let's run our model. Okay, now what happened? Anybody want to weigh in on what the heck happened here? bugging me that I can't remember where that friggin'
It's exponential growth because we had feedback from our population.
yeah, so it's not linear anymore. It's growing exponentially. Okay. What happens if we twirl down here? 0. Do we
This,
have
you're not going to get it. It's a flat line.
yeah, because we're starting with no rabbits, right?
Right.
So we fixed the conceptual problem and it's mathematically sound, right? So unit warning. I wonder if
What's the little sideways this thing mean? I always get confused when it says that.
not what do you mean?
The initial population, the sideways 0 with the slash through it.
Oh, I think that's because we haven't hit the U-turn.
Oh,
You hit the U-turn, it goes away. So I'm wondering if using this unit. Oh, here we go. Unit editor. Here's where they're hiding it. I knew it was. I was like, I know I've seen it. I can't remember where they stashed it. So over here, you can say my unit definitions, add to my unit definition. So, so it would be rabbits and bunnies. Okay. Add to my unit definitions. And what is this? Add to model specific. Okay. Units, right? What is this saying? Rabbits per year, bunnies per year. Oh, so I think, so this, you got to be careful here too. A lot of these units checking things are persnickety. Let's see. These are mathematically the same. Let's see if that fixes things. What is it saying here? Birth rate has rabbits per year. Bunnies. Did I say bunny or bunnies?
bunnies.
Did I say bunny or bunnies?
Bunnies, plural.
Rabbit years. Okay. So let's try and fix this. Let's see. Doesn't like bunnies per year. But rabbits. Let's try bunnies per. Bunnies, what's it say? Raised to the 2 over rabbit years. Doesn't make any sense. So yeah, let me make sure. Rabbits per year. Oh. So what if I say, yeah, I think that fixed it. See, it's persnickety on some of these units. You told it they're the same thing, but I had to, in this equation, literally make it rabbits per rabbit to get it to be rabbits per year, even though it knows they're the same. That's kind of clunky. I don't like that, but at any rate, all right. So now our units are okay. A little bit of fiddling. Looky here. See, we got a red. Why is it red? It's sort of rust red. Why do you think it's red? That's for a reason. It's just not arbitrarily picked. By the way, you can expand these things here. So we had loops that matter, and it found one feedback loop, and it says it's responsible for 100% of the behavior of the model. And it's a reinforcing loop, a positive loop. So it's red for reinforcing. If you want to see it, so there you hit the flashlight. Okay. And you can say, create a causal loop diagram for it. So it'll do that. See, it changed up here. We can go back to the stock flow diagram, or just give me the causal loop diagram. So that's kind of nice. And you can make that bigger or smaller. So we don't need loops that matter to tell us that there's one loop and it matters.
Right.
But when you have a complicated model with nonlinearities and they're shifting feedback loop dominance, this tool is very helpful in figuring out why the model is doing what it's doing and if there's shift in loop dominance. Okay, now we started with 10 and we had 20 rabbits about year 35, right? If you look up at the graph there, it's 20.1, but we're at year 35 with rabbits is probably months. I should do it. So around month 35, we have 20 rabbits. We went from 10 to 20. So that's doubling, right? So remember when we looked last time at the doubling time, it was 70% of the time constant. And the time constant was what? 1 over the coefficient. So 1 divided by 0.02 is, it would be 100 divided by 2. You move the decimal point. So 100 divided by 2 is
50.
50. 70% of 50 is the doubling time. So 70% of 50 is 0.7 times 50 or 35, right? So at month 35, we should have twice the number of rabbits. And remember, we found that from the exact analytical solution with E and all that. Well, now we're seeing it again with simulation. Now, it wasn't exact because we're approximating it, right? So this is the first molecule from last time. We solved it analytically and all that stuff. I did my treachery. I switched from a delta D to a small d and all that. And we did the log cabin and all that stuff, right?
Mm-hmm.
So that's molecule number 1. Okay, cool. Well, remember we said we had and look at what I'm going to do here. I'm just going to pull this off. Oh, by the way, remember we talked about challenging the clouds? If I go like this, now I said I want to get rid of the cloud, the hole in the fence, and I want to keep track of stuff. And if I say, no, I don't really like that, I can get rid of it. Of course, I can always undo stuff. Okay. So let's get rid of this for now. Or actually, we don't have to get rid of it. I'm going to take this and stick this off to the side for the moment. Let's get another flow. Let's call this death rate. Let's say we're losing 2 rabbits per month. And we're starting with, let's start with 100 rabbits. And let's run our model. Oh, sorry. All right, so run now. Okay, so we start with 100 rabbits and we're losing 2 rabbits every month, going out for 100 months. And what happened?
We have a negative number of rabbits.
So right around 49, month 49 or so, 49 and a half or whatever, we ran out of rabbits. But what happened? The model kept killing rabbits, even though there were no rabbits to kill. and we have negative rabbits. No good. Now, sometimes you can have now remember this Barry Richmond thing, this legacy thing, non-negative stock. If we had used a non-negative stock, it wouldn't have done that. It would have just gone and snapped off at 0. But that's bad modeling practice. That's a legacy thing. So the death rate equation is not good. It's mathematically correct. The model will run, right? But it's foolish, right? Having negative rabbits doesn't mean anything. Now, if this was cash and the death rate was our spending rate, or let's say this was, let's say it's our checking account, and this is our spending rate, can your checking account go negative? Yeah, you can overdraw your checking account, and if you have overdraft protection, it's okay. The check will clear or your debit card will work, right? But now, so you'll have negative money in your account, but the bank calls that what?
Overdraft.
Yeah, but what do they call it? What is it really?
It's a charge to your credit card that's linked so that your check still won't bounce.
Yeah, but it's to the bank, it's a loan. The bank just gave you a loan. So you have to pay back, let's say you overdrew by $10, you got to pay back the 10 and interest. Banks make money by making loans. So as long as you're a good credit risk, as long as you pay back your loans on time with interest, they like you. They'll lend you money constantly because that's how they make their money. So they're happy that you overdrew because you're going to pay them back and with it and give them interest on the loan. Now, if you don't pay them back, that's where they don't like you. Now that's a problem. As long as you pay them back and pay the interest, you're good. So it's a loan. So you can interpret negative cash. How about, so your stock with negative cash would be then interpreted as debt, you know, or, and it's a liability to you. And it's an asset to the bank, right? Because they've made you a loan, right? If this was inventory and this was sales and we overdrew our sales, overdrew our inventory. Now you can do this in the beer game. In fact, the beer game is set up explicitly to do this. So you can be stocked out in the beer game and actually have backlogged orders, which in the beer game is negative inventory. So negative inventory can be interpreted as backlogged orders. Okay, you didn't ship anything, but it can go negative. So my point is that sometimes your stock can go negative and you can at least interpret it, even though it's maybe not best practice. Sometimes, as you'll see in my Romeo and Juliet model, negative values of emotions are anger or dislike, and positive are like, and 0 is neutral. So sometimes you want your stocks to be able to go negative. So sometimes you want them to go negative. Sometimes you don't want them to go negative, but if they do, they're interpretable. And then most of the time, you don't want your stocks going negative. Negative rabbits doesn't mean anything. It's meaningless, right? By the way, if this was, you know, your checking account and this was your spending rate and you overdrafted, it's better to have a separate stock of debt rather than to have negative cash. And, you know, and if this is inventory, you'd prefer to have backlogged orders as a separate stock rather than interpreting negative inventory as backlogged. But you could do it, right? But most of the time, we don't want to do that. Most of the time, we don't want this situation that the outflow or flows keep outflowing when there's nothing in the stock, driving it below 0. No good. So Suzanne, what's the fix as before?
It's a feedback loop.
Need a feedback loop. So feedback comes to the rescue. So we're going to make a loop here. And we're going to need a coefficient. We'll call this average lifespan. And guess what? Stella's going to say, look, you connected these 2 wires in here, so you're going to have to use them somehow. So this is rabbits, and this is going to be in months. So let's say 50, these things live 50 months. I don't know how long they live. 50 months. And we're good. So see how the dimensions worked out? I know this is in rabbits. I know this is in months. And this has to be in rabbits per month. So how do I combine these two things? I have to divide. So knowing that stocks are in terms of units, flows are in terms of units per time, and that always has to hold, helps me to think through my equations. Stella's not going to know you divide here. It's just going to say you got to combine these somehow. How did I know to divide? I know the dimensions. Okay. So let's rerun. What happens now? If we rerun, oh, it's looking like the problem is probably solved. You know, if we run this thing out a little more, we're asymptotically heading to zero, but we're not going to go below that. Now, how do we know? Oh, by the way, if we look at loops that matter, what happened here? It's going to say, oh, there's one loop. Now it's blue for balancing, red for reinforcing, blue for balancing, negative. So those colors were chosen purposely. It says I found one loop. It's a balancing loop. See, it's saying B here instead of N for negative or something. And the flashlight says there it is. And it accounts for 100% of the behavior. The weird thing is there's no identifiable loop here, right? It's the nomenclature, the way the software is set up, it just doesn't. With the positive loop, you can see it, but with the negative loop, you really can't. And that's unfortunate. Remember, this is your third molecule. We looked at that in exact analytical form the other day, right? You have an ice cube melting on a hot asphalt driveway. You have a drug being dissipated from an animal system or a human system through perspiration and spitting and breathing and all that stuff. You have the decay of a radioactive isotope. You have the depreciation of plant and equipment. You have the dissipation of a electromagnetic energy from a capacitor and an inductor and a radio. So don't touch it until with a screwdriver until it's dissipated away, right? It's the sister molecule to the positive loop we had before, right? It's exponential decay. It's a negative feedback loop system with an implied goal of zero, right? So we looked at half-life as the sister concept to doubling time. So how long does it get from 100? Does it take to get from 100 to 50, right? So 50 is, where is it? Yeah, we're close. Right around month. What is it again? 35. 70% of the time constant. What's the time constant? This guy here, 50. 70% of 50 is 35. Half-life, right? Yes? So we looked at it analytically last time. Now we're looking at it in simulation form. But you see the same thing. Three of these, three time constants, so it would be 50 plus 50 plus 50 is 150, gets you 95% of the way to the goal. The goal is 0, and we're at 150, we're at 4.93. 95, we lost, started 100, we're headed to 0, we're 95% of the way, we lost 95, we're down to 5 after 3 time constants, right? For electronics, you need 5 time constants out here before you touch it with a screwdriver, so you don't get shot. It's not months with electronics, it's milliseconds or picoseconds or whatever, so it's really quick, but still, you know, okay, it's to discharge these things. Yes, so you should be saying, oh, we've seen this before. Yes.
What do they call that rule where it's 3 time constants gives you 5% less? What's the rules called?
I don't know if there's a name for it, to be honest.
No.
But there is a name for this. Look at this. this equation works, right? But looky here. If the population is 0, what's the value of the flow?
0.
Is that good or bad?
That's bad.
If the population is 0, the death rate, the outflow is 0 is bad. If there's no rabbits to die, we're having no rabbits dying is bad.
It's just neutral? Like it's just neutral?
Well, it's what we're saying is we don't want negative rabbits. So
Right.
the equation says when population of rabbits is 0, the outflow is 0. So stop killing rabbits when there's no rabbits to kill. Yes?
Mm-hmm.
Okay, so it's conceptually correct, and there's actually a name for this one. It's called Little's Law. And so Little's Law is very important. So we're going to make it bold. We're going to make it red. And we're going to make it big, indicating great importance. So Little was a marketing professor at MIT, and he was the first one to prove that in the steady state, sorry, my bad. It's not Little's Law. Thinking ahead. This is first order control. We're going to get to Little's Law in just a minute. First order control. So first order control says when you have an outflow or outflows from a stock, and if the stock is not supposed to go below 0, meaning the flows need to shut off when there's nothing in the stock, you need what we call first order control. Okay, so this equation has it's what button am I in here? I got to be in that button. That's, you get confused. This equation has to be correct in terms of, in this case, the biology, but it also has to be correct in terms of the logic. There's the basic logic. It doesn't matter if it's rabbits or whatever. You can't have negative whatever. We can't have negative rabbits. So the equation also has to say, shut off the outflow when there's nothing in the stock. So you got to have the biology or the economics or the physics or whatever correct. And then you have to have the modeling stuff correct, all in the same equation, or there's problems. Now here, it's pretty straightforward. No big deal, but it can get more tricky as we go along. There can be multiple outflows. They can have different priorities. There can be stuff pulling, there can be stocks pulling stuff out of a stock. This stock is just decaying away by existing, right? So it can be more tricky is what I'm getting at. But for now, that's called first order control. So if you're a system dynamics professor and you're grading or evaluating somebody's model and you see outflows, one of the first things you do is say, do those outflows need first order control or not? And if they do you have first order control? Or are you going to get weird stuff happening when you got negative rabbits or something going on? Okay?
Okay.
That's good. Everybody's cool with that? All right. So again, fairly straightforward, I suppose. Now, notice
I have a question.
Yeah.
So I just remember being tortured when I was taking calculus that it says no matter how far you go out there in months, you're never going to have completely 0 rabbits.
Yes. It's
Right.
asymptotically approaching 0. That's right.
Yeah. But it
Zeno's
never really
paradox.
does.
You can walk from here halfway to the wall. How many times can you do that? Can you, wherever you're standing, walk halfway to the wall, then walk halfway to the wall, and walk halfway to the wall? How many times do you do that?
I finally
Never reach the wall.
Yeah, but I mean, to me, at some point, I'm going to look in that in that cage where the rabbits are, and there's not going to be any rabbits that
So
are alive.
you want to do discrete modeling then? You either have one rabbit or two or zero. You're not going to pull taffy. You're going to do discrete modeling. That's where, remember we said the problems with system dynamics, some people cannot make that conceptual change.
Mhm.
That freaks them out.
Well, when you're talking about whole units, it did freak me out. Finally, the professor just said the two lines never really touch. You have to accept it. Let's move
Now,
on.
yeah, and because it's an artifact of continuous time model. Now, if that, you can either say I'm not going to do system that, or you can start going to this stuff over here, the discrete stuff for
Okay.
these sorts of situations. So there are techniques for this, but yeah, that's right. So that you just got to say I'm comfortable, or I understand. It's not real. That is not real.
Okay.
So it's an artifact of the idea that you're doing continuous time simulation on a digital computer, right?
Okay. Got it.
All right, so we push on. So let's go back to that first molecule and let's use them both now. So I had pulled that apart. I'm going to put everything back now as I had it before. I have to do a little bit of tinkering here to get it back to where it was. And so we said it was population times the fertility coefficient. So now I have those two molecules, the one with doubling time, the one with half-life, exponential growth, exponential decay, heading to zero asymptotically. And I'm going to use both of those molecules together. Now, I don't have one that says population and the other that says pop, or pop rabbit and rabbit pop or something. We use one stock. But now we have the two molecules joined together. And this leads us to an important, super important system dynamics concept, which is big models come from linking small models. So that's what we did here. We have two small little models, molecules really, and we linked them together, joined them. We didn't join them before we knew all about how each one behaved. Half-life, doubling time, time constants, all that stuff. And then when we were familiar with how they behaved, this one also has first order control, etc. We were now confident that we can join them and nothing silly is going to happen. Okay, you don't want to do that, put stuff together until you've tested the components in isolation and thoroughly understand what each thing is going to do. Because when you got this gargantuan thing and stuff's going left, right, up, and down, if something passes something to something that's goofy, it blows the whole model up, and then you're like, where is it? I don't know where what's causing the problem, right? So you have to be disciplined here. And see, we got two, it's a first order system, one stock, one independent stock, but now we got two feedback loops. Each of them is a minor loop, right? Because each loop goes through only one stock. So there's two minor loops. Now, by the way, and I don't know if it's going to ask me to log on here. So it didn't ask me to log on, but I opened the assemblies window. So I went over here to the assemblies window where it says Windows Assemblies window, right? And if I say compounding, look at this. So I can add this to the model. Oh, come on. I did this before. This is a new feature. Oh, you know what? It probably wants me to do that. That's what it gave me, the crosshairs. So let's look over here. Stock times compounding fraction, right? And here it's initialized inside. They're initialized at 100. And here it's 0.01. I said 0.02. But do you see? I don't have to invent that. there's a whole collection in the assemblies area of these things that as you go along, you become familiar with them, then you just grab them and use them. Right? Molecules, generic structures. Okay, so I have two feedback loops here, two in isolation, two first order feedback loop systems, a positive and negative loop. I've combined them because I understand in isolation how each of them work. Anybody want to guess what's going to happen when I run these guys?
They're going to work against each other essentially to create some type of oscillation
Okay, let's see.
or not.
Oh, we got equilibrium.
Equilibrium.
So the two feedback loops were of equal strength. So they cancel, you're right, they worked against each other and canceled each other out. Now, in continuous time, you cannot get oscillation without at least two stocks. So there's no way it can oscillate, but it's canceled. Now look at the loops that matter. This is, I don't know if this is a bug or it just is, but there's clearly two feedback loops here, but it didn't find any because it's an equilibrium. So equilibrium kind of throws that tool off a little bit, I think. I'm not sure, but looky here. If I were to make this loop stronger by making this fertility coefficient bigger, the rabbits are more productive in making baby rabbits, what's going to happen? This loop is going to be stronger than this loop because now they're in balance. What's going to happen?
You're going to have population growth.
Okay, so let's do that. So let's boost it. If we get it exactly to, it's hard to get it. There it goes. So it's 3. So it's 2% out, 3% in. Okay, now we got exponential growth. And what happens now? Now it finds two loops. It says, okay, there's two loops there. In total, the positive loop is responsible for 60% of the model's behavior and the negative for 40%. Okay,
So
you can see the contribution up here.
yeah, so it seems to me that the accuracy of the model depends a lot on the coefficient and the accuracy of the coefficient to reality. Is that a big focus in systems dynamics?
Okay, so great observation. So feedback poor, if you go back to the slideshow on, or the tape, the videotape on characteristics of complex systems. Remember, we broke system dynamics modeling into, and then we looked at systems. One of the conversations about the characteristics of complex systems is that complex feedback systems are very robust with respect to parameter values. They don't change very much with respect to changes in parameter values. You can vary the parameters 20% in either direction and nothing much changes. Unless you find a leverage point. Remember this thing? Then a little change in a parameter, you get a big change. But those are few and far between and hard to find. That's why you need the model. That's only true for feedback-rich system dynamics models. This is not a feedback-rich model. There's no counteracting negative. Why does that occur in a feedback-rich model? Because there's negative feedback loops that are goal-seeking, trying to hold the system, stabilize it like a thermostat or a cruise control on a car or a guidance system. It wants the missile right on target. And if the wind blows it off, it brings it back. So that's why with a feedback-rich model, which is more realistic, they're insensitive to parameter values. You can vary them 20% in either direction, it doesn't matter. But little models, little teeny ones like this are very sensitive to, so with a full-blown research level system dynamics model, that doesn't mean you go willy-nilly and you go, I don't care what the parameters are, it doesn't matter. No, it matters. You give you a good effort to try and guesstimate what they are, talking to people, using data, whatever. But you don't obsess about it because it mostly doesn't matter unless you twiddle it a little bit. You turn the wheel ever so slightly and you get a big change in the model's behavior. Then there's something there, right? So that's why Forrester said, why do you economists always spend all your time trying to statistically estimate parameters of models? It doesn't make any sense. Because he said, because your models are feedback poor. You don't have a lot of feedback loops in them. And you should have feedback loops in your models. So yes, feedback poor models, little models like this, they are very sensitive to parameter values. Yeah, but bigger models with a lot of loops are not.
Okay.
Okay, so let's look at a couple of other things here. I know I'm running out of time here, but I want to complete this discussion because I think we're hot on the trail of something here. So another thing that's very common in system dynamics modeling is to let's put the parameters back. Is to look at ratios of stocks to flows. And you can get a lot of information from that. So if I were to put down a converter here and say, let's see, better to say, average residence time. And if I were to take telephone wire, see, that's why I said I like to line these up, but a lot of times you can't because stuff gets in the way. And what I'm going to do here is I'm going to specify an equation. I'm going to say population / death rate. So notice what I did here. I used 2 slashes. That's safe division. That says if this thing ever goes to 0, meaning if this thing ever is 0, meaning nothing's in here, this thing shouldn't blow up the model. It'll go to 0. You can also, another way to do that is you could say safe div, here we go. And you could say population, comma, death rate. These are 2 ways of doing the same thing. Safe division. It says if the denominator goes to 0, if this thing goes to 0, meaning this thing went to 0, don't blow it up because you can't divide by 0, right? So anytime you got something in a denominator and it can change, possibly to 0, you want to do this. Okay, safe division.
What does the average residency thing mean?
Just about to tell you.
Okay. Oh.
That's your Little's law. So Little was a marketing, I started to say this before, I got ahead of myself. Little was a marketing professor at MIT who proved that in the steady state, the sum of all the outflows, there's only one, but if there are more, the sum of all the outflows divided into the stock gives you the average residence time of a unit in the stock. How long on average it stays in there before it leaves. It looks simple, but there's actually mathematically a probability distribution associated with the leaving of units from a stock. And so then on average, what's the how long does something stay in the stock before it leaves? That's called Little's law. And we use that all the time. So for example, if this is inventory and this is shipment rate, this would be the average delivery delay. And that might go out to the model, the sales sector of the model, and the sales force is quoting the delivery delay. How long is that going to take to get that to me? I want a Tesla. How long is it going to take me to get one? I'm hungry. I want a meal at your restaurant. How long is it going to take? Oh, 25 minutes is the delivery delay. Or I call up Domino's. How long to get the pizza to my house? 15 minutes. That's the quoted delivery delay. Well, that's what's going on here, right? So that's just a ratio of a stock and its, in this case, outflow.
So his law is special because when you calculate that ratio, it is equal to the delivery delay. Is that right?
not the delivery delay specifically, but the average residency time of a unit in a stock.
Okay.
So how long does something stay in the stock before it leaves? Because, or remember my simulation science presentation, order is not preserved. Right?
Mm.
So stuff comes in, and then so it may, if it's, you know, LIFO, FIFO accounting, last in, first out, first in, first out, or if it's, you know, a gluing process, it matters whether a widget's has been drying, the glue's been drying for 2 minutes or 58 minutes. If it's an hour-long gluing process, order matters. Well, in a regular stock, there is no order preserved. It leaves according to a probability distribution. So you want to say, well, on average, how long does it take before it goes? If you want it like a gluing thing or something, then you got to use a different kind of stock. All right. What other thing is useful to know about here? Let's do this. Let's do a concept called net birth rate. So a net rate is the sum of all the stocks minus the sum of all the flows. Now there's only one stock and one flow, so it's quite simple. Okay, and again, these are going to be, you know, rabbits per month. That's the net birth rate. Now we could have done a net birth rate with a biflow, having births and deaths through the same pipe, right? And that's useful for other things. You'll see next time when we use that. For now, we're separating the ins and the outs. So we have to construct the net flow, the net birth rate in this case. Okay? It's the sum of all the ins minus the sum of all the outs. If the net birth rate, the net flow is 0, it means the ins and the outs are the same. And the stock is not changing. So then we can say population growth rate is defined as, it's kind of like Little's law, but a little bit different. It's the flows over the stock. Over here, it's the stock over the flow. So it's reversed here. It's the flow, the flows, net flow over the stock. Right? So if we run this thing in equilibrium, what's the population growth rate going to be?
0.
Yeah, it should be 0. Sure enough. And if I hit the hourglass and I bump this up to 3, I got 2 going out, 3 going in. On net, I have 1% growth rate. Right? Makes sense? 2% out, 3% in. On net, I got 1%. And you can see the relative strengths if we go, you know, we want to see the loop dominance. You know, you got your 60-40 again there. And you can kind of see it visually there. The lines are thicker for the more dominant loop structure. So we note that we have the 2 molecules so let's wrap up because we're running out of time here. So we had the 2 molecules that we previously saw in isolation. We looked at their exact analytical solution. We derived the positive loop one, and then we just said, you know, here's the other ones. And we looked at, you know, doubling time, half-life, time constant, how it related to E and all that stuff. Then we looked at them in isolation in Stella, and we saw the same stuff, except not exactly because we can't make the thing take infinitesimally small steps. Then we said we can combine them because we know each one what they do by themselves. Now we can combine, and we have a bigger model. Then we looked at, because we got in and outflows, we looked at the ratio of the stock to its outflow, Little's law, or net flow growth rate. It could be negative. If the negative loop is dominant, you'd have a minus 1% or whatever. Negative growth rate, shrinkage rate, whatever you want to say. Okay. Knowing feedback loops fixed robustness problems with the molecules. We had births happening when there was 0 rabbits to begin with. We had negative rabbits. Rabbits were dying when there were no rabbits to die. We fixed that with feedback, right? We looked at the feedback dominance tool, right? That helps us. It's very simple now, but you'll see later, it helps us to understand what loops. So feedback is super important, right? And so getting a handle on what loops are doing what. We said we can convert from the model just to the loops to a causal loop diagram if we want, just for that presentation of the model structure. If we just want to see the loops, an audience or something like that, right? Okay. And we learned, we started maneuvering around the software, getting our bearings as to what's stashed where and whatever. I even had to think of where that stupid definition of variables was, and even still it's persnickety with, you got to use parentheses and stuff. What I'm getting at is here's a place where AI could be helpful with dimensioning, because the dimensions I specified were not wrong, but it was flagging it as wrong. So it doesn't know, even though we gave it some information. So that's a little clunky. The loops that matter tool, when you have 2 loops, but it's an equilibrium, it finds no loops, also is a little weird. I don't know that it's a bug or just a feature of it. It's got to have differences to show up to do its calculations.
I think that makes total sense to me that it doesn't show up because there is no dominant loop.
Yeah, but the error message is that I didn't find any loops. And there's clearly 2 in there. But it might just be an error message that should be, or not an error message, but say I found no dominant loop instead of no loops. It can throw you off. So these are, all software packages have their thing. But by and large, I think, I showed you a good introduction to the basics of the package. Again, this is on tape, so you can refer back to it. If you need to, if you pull it up, your version of Stella, whichever one you're going to have, and start trying to replicate all this stuff. In the Canvas, there's an exercise and a quiz with all the stuff that we're going to do in it, the exact same stuff. So, here's what we'll do next time. What time is it? Oh, we're a little bit over. Sorry. So next time, what we're going to do is we're going to press on here. Remember, I showed you 3. Oh, and by the way, we took a peek at the assemblies window, right? Where you can grab and place into your model existing molecules that are known to be robust and well thought out and whatever. They're sort of in the collection of system dynamics stuff, instead of just individual Lego pieces, small chunks of Lego pieces that others have created that say, hey, it's useful to make a corner of a building or, whatever you're trying to do with Legos. So if you remember with the slideshow from last time, there's 3 molecules. I said they're the big 3. We've looked at 2. Next time, we're going to do the 3rd one. And the 3rd one, I'm saving that. That's the most widely used molecule in all of system dynamics modeling. But we're also going to introduce some other concepts that are like super important. One is using test inputs to examine the features of a piece of structure. So we're going to look at all different test inputs and see how we put the model or the piece of structure into equilibrium and shock it out to see what happens, what we can learn from that. And then we're going to see some issues like something called steady state error, which can be a big headache. And how do you fix it and what have you? And these are all going to be with these first order systems. So there's only one stock. But there's a lot going on with these they look innocent, but there's a lot going on. But you dare not start connecting all these things together until you're quite familiar with all the ins and outs of them, right? Then and only then is it safe to start connecting these things and testing some more. The good news is, once you know them, you don't have to relearn them every time you go to use them. You know them, right? So it's really the first time going through this stuff it's a little bit tedious to understand what they do. And then you begin to be quite familiar with them, and you just grab them and use them as you need. right? And you'll see there's even canned functions in Stella that don't even require you to build or even grab an assembly. You just use a canned function. Again, more advanced. You don't do that until you fully understand the thing when you build it from scratch. But once you get it, to save time, you can take some of these shortcuts and it saves space, screen space. You don't have, it's not as cluttered a diagram. Okay. So that's where we're gonna go next time. So we've begun building models. They're very small, but before you know it, the models will be getting bigger, and you're going to be seeing these same molecules appearing again and again in these bigger contraptions. Okay.
Mike, is there some way you can send me the exercises that are in Canvas so that I can be doing them too?
Yeah, that was the issue of trying to make a PDF or something out of it. Yes, on the exercises, but the quiz stuff, I don't think that's possible to.
I just want to be able to do that. I just want to be able to build.
No, I understand what you're asking. I can't. I must not have done that already. Because there's that one.
No, you didn't, because I've been waiting for some of the other stuff that has links and I haven't gotten a PDF
but there's a depository somewhere. I can't even remember whether I gave you guys that has, like, I cleaned out everything I had, right, of all the PDF stuff. It's in it like a Google Drive, right?
I'll go. I don't remember that, but
I believe I spent a lot of time doing that, so I know.
Let me go look.
But I don't know if I PDF the Canvas exercises.
Okay.
That I don't remember.
I'll go back.
If I didn't, I can do it.
You sent me a link to the Google Drive with all the stuff that you put in there, right?
Yeah, I think it's sent it to everybody. Yeah.
Okay.
So if you can't find it, let me know. Send me an email.
Okay.
And then the key is, did I PDF those? I did it so long ago. I can't. It was like the first week, so it was like 8 weeks.
And then the other question was, you mentioned something about a book that Donella Meadows did of all of there was a collection of articles that she wrote in that syndicated column. What's the name of that book? I wanted to get that.
The Global Citizen. Hang on, let me see if I can.
The Global Citizen?
So hang on. I think I have it on the shelf.
Okay. And it's just all that syndicated column, it's those articles that it's a collection of those articles that she published.
Yeah, there's a lot of them, a whole book of them.
Okay, I'll see if I can get that.
Yeah, it's Island Press.
Okay.
All right, well, there you go. There's a lot to chew on.
That was very helpful.
What's that?
That was very helpful. I mean, it just filled in a lot of holes for me. I mean, I understand those concepts, but just the orientation just kind of solidified that a little bit more. It's kind of like you have to think about it for a while and play with it for a while, and then
it's like swimming and driving. Just hearing me do it, you can't do it. You got to start playing around with the software.
Yeah. Yep, I'm gonna have to do that. I think I have to upgrade my software. I'll have to contact those guys.
Okay, yeah,
I should have done it in July. Huh?
So one of those things, you need to do this stuff. You need software. Yeah, you gotta.
I have the software. I just don't think, and it works. I just don't have the current version. I don't know, and so I just need to upload that. I've got almost the current version, but I just have to go back and do that, up my game there.
Yeah.
Kareem was very generous. He gave me a PhD license, which is much cheaper than the commercial one, but it's not the architect. I can't do the architect stuff, but
that's well, so we're gonna, we have a separate course. Well, Colin teaches an undergraduate course in gaming, and I think I'm going to develop a graduate course in it. It's like, okay, you have your model now, conforms to good modeling practice. How do you turn it into a game? Multiplayer, single player, all the different, that's a whole area, a whole giant area. where, you know, is it a board game? Is that where the computer's involved, but it's in the background? Is it a computer game? Is it over the internet? Is it, you know, it's endless, right? So, but how do you do that? Like always, it's easy to do a crummy one. It's hard to do a good one.
Good one.
So, yeah. So we'll touch on it at the end, but we don't, you know, you don't need Stella Architect for this course. Because we'll just at the end of the course, we'll say, and you can make games out of it. Let me tell you a little bit about gaming in general, and then the course ends.
Okay. Thank you very much. It was excellent.
Alrighty. Everybody have a good week. We'll see you next time.
All righty. Thanks, Mike. Bye-bye.
Bye.